Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today we will be looking at the world's first production 8-speed front-wheel drive transaxle. This is made by Aisin AW Corporation out of Japan, and this transaxle is used in many different automobile manufacturers' vehicles. As far as I can tell, the first one to use it was Volvo. They used it since 2014 in many of their front-wheel drive vehicles. Lexus has used it in their 2017 RX 350. General Motors used it in a Cadillac XT5. Buick used it in a LaCrosse. Toyota's used it in the Highlander for 2017, the new 2018 Camry, and any other 8-speed 2017-2018 Toyota Lexus vehicles in a front-wheel drive will have one of three versions of this transaxle, as far as I can tell. The three versions are they're all designed to operate the same way, but they're different levels of how heavy duty are they, how much torque can they handle. This transaxle design is actually based on an earlier 8-speed rear-wheel drive transmission designed by Aisin also, that was used in the 2008 Lexus ISF. So we've got this rear-wheel drive transmission here that I did a video on several years ago on how this unique transmission works. What's really unique about this transmission is that it only uses 2 Planetary gear sets. Now, unlike the General Motors 8-speed, the Hyundai 8-speed, the ZF 8-speed, they all have 4 Planetary gear sets in it. This one only has 2, and it still gets the 8 speeds. So it's a very unique and patented design. What it has is a Ravenel Gear Set in the back and a simple gear set in the front. And you combine the two and you get what's called a Lepelletier gear set. But then they've gone a few steps further and have modified the way the Lepelletier gear set worked, because Lepelletier only gave us 6 speeds. This is 8. So they figured out a way to get 2 more gears out of the Lepelletier gear set design. Well, this new front-wheel drive transaxle is the same design as the rear-wheel drive transmission. The only difference is the ring gear, the internal gear of the Ravenel Gear Set now drives a counter-drive gear for a front-wheel drive rather than going to the output shaft on the rear-wheel drive. So this transaxle stack-up of gears here is exactly the same as this rear-wheel drive transmission stack-up of gears and clutches and so on. It's just miniaturized greatly. And so we're going to take a look at the operation of this transmission, look at the major components, what's serviceable, what's not serviceable, how to check the fluid level, and all of that. But to begin with, let's take a look at the transmission case here. Now I've gutted the case, it's empty, but I've just put it back together so we can see the outside of it here. This is the bottom of the transaxle. There's a hole right here where a band servo is going to come in for applying the band. There's a pressure tap here, I believe, for line pressure. And then there's a fluid level check and drain plug right down here. If I unscrew the fluid level drain plug and take it out, you can see that it actually has a real tall straw as part of it, and then it has a plug in the center of this drain. If I take that plug out, that lets us see all the way through that straw. And what this does is, to set the transmission fluid level properly on this transmission, you bring the transmission fluid temperature up to the proper temperature, and then at that temperature the fluid will have expanded to where if it's too high, the fluid will just come up and go out the straw and drain out the bottom of the transmission into a pan. And that's what this inner plug is for right here. If no fluid comes out, then you add fluid until it does. Now the fluid that goes in this transmission, if you're at a Toyota or Lexus shop, then it is the Toyota World Standard fluid. If you're at the Volvo or General Motors shops, then I'm sure this is rebranded to some other name, but it's the same spec as the Toyota World Standard fluid. All right, we also have, if we come around the side here, there's a fluid fill port back here where you can add fluid. There's a vent right here. There's a couple of plugs that aren't user serviceable. They're just for drilling passages and plugging those holes. There's another fluid fill plug right here, whichever one's easier to get to. And then on the top of the transmission here, there's one more fluid fill plug that may or may not be accessible. And oh, by the way, they tell us on these fluid fill plugs that if you take a fluid fill plug out like this one and it does not have an O-ring around it, that you're supposed to throw away this plug and buy a replacement plug that has an O-ring on it. Why didn't they come with O-rings all over? I don't know, but just a little tip there. This particular model of Transaxle has the transmission control module and transmission range sensor all built in, and it just plugs right into the internal wire harness on top of the transmission here. So this is the transmission control module. Some transmissions have it inside the transmission, others have it outside with an external harness. This one goes right on to the electrical connector for the internal harness. So as you bolt this down, you've got to make sure that it's fully seated first before you bolt it down. Otherwise, you could end up with some poor connections, which apparently has been a problem on this. And if you have poor connections, then it can go into default gears. And the default gears, if you lose power on this transmission, are either 7th gear if you're going under a certain speed, or 8th gear if you're going above a certain speed. And that's not going to be very fun to drive because both 7th and 8th gears are overdrive gears. All right, then we've got the side cover right here that the valve body would be underneath. If I tip it on its side here, there are 3 pressure taps right over here. The C2 clutch, the B2 brake, and lubrication are all right here. This top one here, the C2 clutch, that is part of the actual line pressure check procedure. You're going to put a pressure gauge in that hole. And then it's got a strange line pressure check procedure because you actually check pressure at 2 different locations. So it's going to also have you check pressure right here on this tap, which is for the C1 clutch. So we've got the C1 and the C3 clutch and the C4 clutch pressure taps here on the front, and then the C2 and the B2 brake taps on the back. So there's taps all over the place. You got to make sure when you do the line pressure check that you're in the correct tap, at the correct point, at the correct RPM. Otherwise, it can make you think that you've got a problem there. All right, the model number of this particular transmission from Aisin is a TG-81SC, also known as the AF50. Depends on what vehicle manufacturer it goes in as to which one of those they go by. But let's separate the case halves of this thing and take the components off of it and look at the internal components. Let's get this oil pan off first. This oil pan is sealed, or the side cover, I mean, is sealed with the Toyota FIPIG, the form-in-place gasket sealer, that orange-colored sealer that you see on the case halves of Aisin transmissions. There is no gasket on this, so it's very difficult to remove. There's a special procedure so you don't bend the pan when you remove it. You get all the bolts out, it doesn't want to come off, and there's a kind of a thin wedge that you put in here to pry it out and off, and then you can see sort of some leftover FWD sealant that's on there. By the way, this model, as I've shown you, does not have a dipstick, but there are some that actually have a tube that comes up and out of here where it does have a dipstick. So I think it depends on the vehicle manufacturer as to whether or not it has a dipstick. Now, under the side cover here is where our valve body bolts up. We have 2, 4, 6, 8, 10 different solenoids on this particular model. There might be 9 solenoids on another model. It just depends on whether or not that vehicle has the auto stop or the idle stop feature. As you can see, lots of fluid transfer ports since the valve body is in control of a plane. We have 5 clutch packs on this transmission. 4 of them are for rotating parts of the Planetary gear sets. One of them acts like a brake where it stops a component of a Planetary gear set and keeps it from rotating. So 5 sets of clutches, one of them acts as a brake. Now, as we unbolt the transmission control module here, I want you to see it has the electrical connector right there, and then there's an internal harness that comes through the case that this plugs into. Once again, this has to be fully seated by hand first before you put the bolts in and tighten it down. So keep that in mind. All right, let's separate the case half. A couple of pry points here. When this is sealed with the FWD sealant, it's fairly difficult to get those two to separate from each other. So, looking at the front case half here, here's the bell housing side. We have a real thin torque converter that fits in here with this 8-speed transaxle. And then on the back here, we have the main stack up of gears and the oil pump that line up with this hole. We have the counter-driven gear that's going to go right here with that bearing. And these are roller taper bearings, so they are preloaded. There's a special preload check procedure to make sure that they are loaded properly. Okay, down here in this big area is where the final drive assembly is going to sit, and I want you to see how big this thing is. It's very wide. We have an overall gear ratio through the counter gear from the counter drive gear of 3.075 to 1 on this particular transmission, but there's different gear ratios available depending on which transmission model we're talking about. But one thing that you don't see a lot of on a front-wheel drive transaxle is right here. We have a 4 pinion differential. That's for some heavy-duty torque. The more pinions that there are, the more torque it can handle. Most front-wheel drive transaxles have a 2-pinion differential, so this is double that. It's a big, heavy-duty case, and like I say, they put this in small SUVs like the Lexus RX 350, the Cadillac XT5, and so on. So it's made for heavy-duty operation. All right, and it also has to be preloaded with shims underneath the bearings. There's a special procedure for that. As the ring gear rotates forward, there's the front of the vehicle, so it's going to be rotating this direction with the tires. It's going to fling oil up and around for sling lubrication, it's called. All right, let's get the bell housing out of the way. Let's bring the back half of the case in. Here on the back half of the case, obviously the differential ring gear is going to be sitting right here, spinning, flinging oil up and around as we've talked about for lubrication. You can see the selective shim right here, and there's another one under this one for the bearing preload on the final drive and the counter drive gear. We have in the bottom of this case here the B2 brake piston and return springs. Now on this particular transmission, I've not removed that piston. It takes a great big wide piston compressor to get in there and compress it without destroying the return spring. The return spring assembly is a very flimsy looking piece, and you might be able to get the snap ring out and get that piston out of there, but I don't think you're going to get it back in without a special service tool or making some sort of a tool to properly compress that piston and get it back down in. I have done some exploration on this transmission since I've never seen one or been inside of one before. On these 8 speeds, I've gone through and figured out which passages are what, as far as what they do, to the best of my ability here. And I've labeled all of those. Once again, we've got 5 clutch packs to apply, lubrication, cooler flow out to the transmission cooler, torque converter, clutch control, and so on. Just pretty much the same as any other transmission or transaxle in the past. All right, so it wasn't difficult to disassemble. I didn't really see anything totally unique in this transmission, except for being surprised that it still had, or not still had, but being surprised that it had a band at all. Bands, I thought were history. So there's a band anchor pin right here. It unscrews. On the band itself, there's a hole right there. The band anchor pin is going to sit right there. And then we've got a band servo pin that comes in on this side and squishes it and makes it smaller, which grabs the drum that it wraps around and stops it from rotating. It's like an inverse brake drum, or an inside-out brake drum. You're supposed to remove this anchor pin to get the band out and reinstall it properly. Okay, the next thing I want to do is do a comparison of the transaxle design to the transmission design. Front wheel drive versus rear wheel drive, and then we'll go from there. All right, we will start from the bottom of these transmissions. I want you to notice that both of these have a C2 clutch that is applied in 5th, 6th, 7th, and 8th gear. They both have a Ravenel Gear Set assembly, which is this bottom part. And then right next up is the B2 brake clutch. Now, for those of you not familiar with the term brake in an automatic transmission, it's just simply a clutch pack, but when it applies, it stops this component from rotating. So we've got a C2 clutch, a B2 brake, and then we have an F1 one-way roller clutch that's only used in first gear. So it's going to hold in first gear and freewheel or overrun in 2nd through 8th gear. So 3 identical components in a row. Then on the front wheel drive, we have the ring gear that comes up and connects to the counter drive gear that drives the counter driven gear and the final drive ring gear. for a front-wheel drive. On the ring gear on the rear-wheel drive, it goes down through this shell and goes to this output shaft for the rear-wheel drive assembly. So the ring gear on the front-wheel drive goes to the middle, the ring gear on the rear-wheel drive goes to the rear. If that ring gear moves, the vehicle moves. The next thing is we have a C1 clutch pack that's used in first, second, third, fourth, and fifth gears. Right above that, we have a C3 clutch pack that's used in third, seventh, and reverse. Then we have a C4 clutch pack that's used in fourth and sixth gear. And then we have a B1 brake that's used in second and eighth gear. Now the B1 brake on this heavy-duty, high-performance rear-wheel drive unit is accomplished with a multiple disc clutch pack. It'll stop this housing from rotating. On this front-wheel drive unit here, the B1 brake will wrap around this C4, C3 clutch drum, and when applied, it will stop it from rotating. So the same B1 brake assembly. Then at the top, we have our oil pump housing assembly and stator support that actually goes down inside of the front Planetary gear set, the simple gear set, and is splined to the sun gear of that simple gear set and prevents it from ever rotating. So the sun gear is constantly locked in place. So identical transmissions as far as power flow. How that power flow is accomplished is pretty much identical, with the exception of this band here on the light duty versions. But on the more heavy duty versions, it's also a clutch pack that acts as a brake that would stop this same housing from rotating. All right, let's take a look at the actual components that we have here. On the top here, we have the oil pump assembly, stator support, oil fluid passages. The oil pump assembly is a trochoid style oil pump. Then we've got our B1 band brake, and then our C3, C4 clutch housing. And the unique thing about this housing is that it has two clutch pistons in it. The inner piston is for the C4 clutch, the outer piston is for the C3 clutch. But you'll notice that there's a bunch of rivets around the inside there of the C4 clutch piston area. And what that does is it bolts down the internal parts that separate the C4 clutch piston from the C3 clutch piston, and it bolts it down on top of the C3 clutch piston return spring, which means all those rivets take the place of the snap ring that normally would have held down the C3 clutch return spring, and that means the C3 clutch piston in this outer housing here is not serviceable. If it's leaking or bad, or for whatever reason you think you need to change it, you've got to buy this entire housing to replace that. The only reason I can think of that they did that is for miniaturization of the transmission components. Over here on the rear-wheel drive version, the housing that the C3 and the C4 clutch pistons are in is totally serviceable. You can get both sets of pistons out. All right, the next thing that we have to look at here is our input shaft. And I want you to notice the input shaft is also the planet carrier for the first Planetary gear set of two that are in this transmission. Now the sun gear of this gear set is down inside here, and that sun gear, let me get it out of there. This sun gear right here is held stationary at all times. So if we bring back in this oil pump assembly here. On the back side of the oil pump assembly, on the back side of the stator support, we've got those splines right there. This sun gear is going to spline right there and be held solid. It does not rotate as we drive down the road. So that means that as the input shaft rotates, as driven by the torque converter in the engine, it's the Planet gears are going to be walking around that sun gear. And by the way, there's inner and outer Planet gears here just to reverse the directional rotation. So that means this input shaft spins at engine RPM when the torque converter clutch is engaged, and that Planet carrier rotates inside of the internal gear here, which causes it to spin at almost half the speed of the input shaft. It's about a 1.95 turns of the input shaft to get 1 turn of the internal gear here. So on this transmission and the rear-wheel drive version, these two components make up the parts that can drive the rear Planetary gear set, the Ravenel gear set, at different speeds. We can either drive it at input shaft speed, which matches engine speed, or we can drive it at about half that speed when we connect it to this ring gear here, or of course we can hold it still and hold it steady to the case. Alright, so the rest of the stack up here are components that connect to the different parts of the Ravenel gear set. So for example, the C1 clutch housing that I just pulled off here is splined to the rear Ravenel sun gear. So we'll take a look at that here in a minute. This little hub piece right here is splined to the front Ravenel sun gear. Now this piece right here splines right to our C3, C4 clutch housing, and so when this housing rotates, it's going to be rotating the front Ravenel sun gear. So we'll set that off to the side. Then we have kind of a heavy-duty center support bearing with our Counterdrug gear with 54 teeth on it, our Ravenel gear set internal gear or ring gear connected right to that Counterdrug gear, and if this gear rotates, it'll turn the counter-driven gear and the final drive housing ring gear and make the vehicle move down the road. So anytime this ring gear rotates, the vehicle will move. So we'll kind of set that off to the side for the moment. Okay, now we can see the front sun gear for the Ravenel gear set. That front sun gear is splined to this housing that connects to the C3, C4 clutch housing, which means whenever that C3, C4 clutch housing rotates, so does the front Ravenel sun gear. So we'll set that off to the side. Then we have access to the rear Ravenel sun gear, and it connects to the C3 clutch housing right here. So whenever this C3 clutch housing rotates, so does the rear sun gear of the Ravenel gear set. So we've got the C1 clutch housing that connects to the rear sun gear. We've got the C3, C4 clutch housing that connects to the front sun gear. So we can drive either one of those at either 1-to-1 gear ratio with the engine through that input shaft front Planet carrier, or through a reduced gear reduction through the front internal gear. So let's look at what's next here. The next thing that we left out is the Planet carrier of the Ravenel gear set, We've got some long Planet gears and some short Planet gears, but it's all just one Planet carrier. It's not separated into two separate ones. This Planet carrier has on top of it here a one-way roller clutch, the F1 one-way roller clutch. So the roller clutch is going to allow this Planet carrier to rotate in one direction only and not in the other direction. Now there is a B2 brake set of clutch plates that can come in and hold the Planet carrier from rotating in either direction, and that's only done in reverse. Then at the back of the transmission here we have the C2 clutch housing with the rear shaft of the transmission, and I want you to see that the input shaft, the front input shaft that turns at engine speed, connects directly to that rear output shaft, and they are always splined together and always turn the same speed. So we can deliver one-to-one engine power to the Planet carrier or release it with the C2 clutch pack down below here. All right, let's put this back together and then we'll go through the power flow, see how we get all 8 gears and reverse out of this unique design of transaxle. So we'll set our Planet carrier back down in first. And we'll put our F1 one-way roller clutch back on. We have to rotate this as we slide it down. Try to get it to go down evenly. Make sure none of the rollers are going to tip out. It's a pretty tall roller clutch. There we go. Make sure it rotates in one direction, not the other. This is the proper direction of rotation if you look in the service information. All right, then we have our rear sun gear. Got to line up. There we go. Then we've got our front sun gear. Just like that. And then we have our ring gear or internal gear that drives our Counterdrug gear and rotates on a big heavy bearing and cast iron housing called the Counterdrug gear support. So we'll set that down in right there. Then we've got our housing that splines to the front sun gear. So if I turn this part right here, the front sun gear will rotate. And then we've got our C1 clutch housing that splines to the rear sun gear. So if I turn this, the rear sun gear rotates. Then we've got our C3 clutch housing that sits right here. That is also the front internal gear. And then we've got our input shaft and front Planet carrier. We've got to remember to put our front sun gear back in the center here. There we go. And a little bushing spacer to hold that in place. And set that down in. And remember, this is going to spline to this C2 clutch housing back here. Let me get that lined up and turn together with it. Then we've got our C3, C4 clutch housing that will go down over the C4, C3, and C1 clutches and spline to the this piece right here that hooks to the front sun gear. But for our power flow demonstration, I'm going to leave this out so that we can actually watch what's going on here. I'm also going to leave off the B1 band. The B1 band, when it applies, as we've talked about, stops this housing, the C3, C4 clutch housing, from rotating, which is really stopping this bottom piece right here, which is connected to the front sun gear of the Planetary gear set. So front sun gear, rear sun gear, that's what these two housings are for, to rotate or stop those pieces. All right, then we'll put our oil pump housing back on with our stator support, get that splined into that front sun gear of the front Planetary gear set. So we have 3 sun gears, 2 ring gears, 2 planet carriers as part of this unique 8-speed gear design. All right, so all those components that we've seen right there are also over here, as I mentioned, except for, instead of having a clutch disc to stop this housing from rotating, this transmission uses a band instead. And why a band? I suspect just for miniaturization purposes of making the transmission smaller and thinner. A band just happened to fit the area, the space, better than a clutch pack did. But I really don't know. I'm just speculating. All right, so to understand how this 8-speed transaxle works, how we can use 2 Planetary gear sets to get 8 gears, we need to understand and think back and remember of how a regular automatic transmission works. In a regular automatic transmission, with a Planetary gear set, there are 3 pieces: the sun gear, the planet carrier, and the ring gear. The way we move the vehicle forward on that type of transmission is we pick any one of those 3 pieces connected to the engine. We stop one of the other 3 pieces from rotating, and the piece that's left over is connected to the tires and makes the vehicle move through whatever power path there may be on a front-wheel drive or rear-wheel drive vehicle. Well, this transmission uses that theory of operation for 5 of the 8 forward gears. We do actually stop something from rotating and cause something else to rotate. But 3 of the 8 gears, we do not do that. We're actually going to, instead of stopping something from rotating, we're going to connect it to a planet ring gear in this simple gear setup in the top here that's just turning slow. It's turning about half the speed of the input shaft. So instead of stopping it, we're just going to turn it at a slow speed, which is a strange design if you've never run into that before. And that's what this transmission did back here. The first time I looked at that transmission and tried to figure out how it works, I was so used to the idea of something had to be stopped that it took me about 2 weeks to finally figure out that no, it doesn't have to be stopped. It can actually be turning at a different speed, and that different speed will result in a different transmission gear ratio. So let me show you the different speeds. We've got a Ravenel gear set in the back here. A Ravenel gear set is just simply a 4-speed Planetary gear set. It has 2 sun gears, 1 planet carrier, 1 ring gear, a front sun gear and a rear sun gear. And on this model, we have first and second gear are underdrive gear ratios, which means the engine will turn faster than the output shaft. In third gear, it's direct drive, which means the engine and the output shaft turn the same speed. And in fourth gear, it's overdrive, which means the output shaft turns faster than the engine. Well, on this 8-speed model transmission, we use first, second, and third gears just the way they are in a 4-speed transmission. So first gear on the 8-speed is the same as the first gear would be on a 4-speed. Same with second, same with third, as far as the Ravenel portion of the Planetary gear set. The overdrive gear ratio from the Ravenel isn't used until 8th gear on this 8-speed transmission. All right, so to understand how this works, we need to look at the front Planetary gear set here. So a Mr. Lepelletier, a Frenchman, is the one that took a 2-speed, basically Planetary gear set in the front, a simple Planetary gear set, combined it with a Ravenel gear set in the back, and gave us a 6-speed transmission. Front-wheel drive, rear-wheel drive, it works either way. But now the engineers at Aisin have modified that Lepelletier design and made it have 2 more gears. And to understand how that works, we need to look at the components here inside the front Planetary gear set. Okay, so we've got the input shaft right here that I'm going to turn with this chisel holder. The input shaft is splined directly to this C4 clutch housing inside right here. So as I turn this handle, watch right here. Notice it rotates with the movement of the input shaft. It's a direct connection, a 1-to-1 gear ratio. And that's because the input shaft is splined right to the planet carrier of the front Planetary gear set. Then the C3 clutch housing here is splined to the ring gear of the front Planetary gear set, and it turns at about half the speed of the input shaft. As a matter of fact, the gear ratio is 1.95 to 1. So it takes about 2 turns of the input shaft to get 1 turn of the output shaft. Now, what that means is that we have 2 different rotational speed devices here that can be connected to different pieces of the 4-speed Planetary gear set in the rear. And in the 6-speed Ravenel or Lepelletier design transmission, he just connected one or the other 2 different pieces here to get the 6 speeds. But what the people at Aisin, the engineers of Aisin, have done is they've figured out a way to connect both of these to 2 different parts of the Ravenel gear set at the same time, and that gives us a different gear ratio than we had with just the 6-speed design alone. All right, so in this front housing here where the B1 brake rotates, or where the B1 brake wraps around and can stop it, we have 3 different clutch packs. We have the C4 clutch pack that turns at 1-to-1 speed with the input shaft. We have the C3 clutch pack that turns about half of that speed. And then we have the C1 clutch pack that can be connected to either of these 2 rotational devices. So the C1 clutch pack is used in 1st, 2nd, 3rd, 4th, and 5th gears. Now this transmission, Transaxle, a Transaxle has the final drive ring gear and differential case and a Counterdrug inside of it, where a transmission back here does not. On this transmission, we have to have 2 clutch packs applied at the same time for each gear. Unlike the General Motors, the German ZF transmission, and the Hyundai 8-speed, all those 8-speed transmissions, they have 3 components applied at the same time. So this is a simpler, more efficient design, and it was the world's first design. So I'm sure it's got patents on it, and the other vehicle manufacturers designed their own after that. So let's go through the power flow on this transmission, see how we get all 8 forward gears and reverse. So in 1st gear, we apply the C1 clutch pack that's applied in 1st through 5th gears. That connects it to the front planet ring gear that turns at half input shaft speed. That always gives us a 1.95 to 1 gear reduction versus the input shaft in the front. And then in the rear down here, the rear gear set, the Ravenel gear set, we have a F1 one-way roller clutch that will hold the ring gear from rotating. So we're holding the ring gear. We are actually rotating the rear sun gear of the Ravenel gear set with the C1 clutch. So we're holding something, we're turning something with the C1 clutch, and that gives us a gear ratio in the Ravenel gear set of 2.69 to 1. But 2.69 to 1 times 1.95 to 1 gives us a 5.25 to 1 first gear ratio on this 8-speed transmission. Now 5.25 to 1 first gear ratio is amazing, because when you combine that with the final drive ring gear ratio of 3.075 to 1, you get really good acceleration. Now if this was just a regular 6-speed transmission, it didn't have the 5.25 to 1 gear reduction in first, and 3.07 final drive wouldn't have been a very good choice. But the 8 speed and 9 and 10 and whatever else may come in the future, they can let us have some first and second and the lower gear ratios in the transmission that allow us to have some pretty tall final drive gear ratios that are really good for fuel economy on the freeway. So first gear gives us 5.25 to 1. All right, in second gear, we're still keeping the C1 clutch applied, connected to the slower moving component of the front Planetary gear set, which gives us a 1.95 to 1 gear ratio. But then we have to apply the B1 band brake, which is applied in second and eighth gear. The B1 band brake, as we mentioned before, wraps around the C3, C4 clutch housing. It has all these little teeth in it right here that's splined to these little tiny teeth at the bottom that drive the front sun gear of the Ravenel gear set. Except in this case, we're stopping the front sun gear of the Ravenel gear set. So in second gear, we are holding these little tiny teeth right here with this drum and band or clutch pack on the more heavy duty models. And we are rotating the C1 clutch at the speed of the slower ring gear here on the front Planetary gear set. That gives us a rear Ravenel gear set gear ratio of 1.56 to 1. So if you multiply the two, the front gear ratio of 1.95 times the 1.56 gear ratio in the rear, you get a second gear ratio on this 8-speed transmission of 3.028 to 1. All right, so that's second gear. So we've held something, we've rotated something for first gear and second gear. Now in third gear, we still continue rotating the rear sun gear with the C1 clutch. But also in third, now we are going to apply the C3 clutch pack, which is up inside of this C3, C4 drum that is connected to these little teeth here that we were holding in second gear, and now we're going to turn it in second gear, or in third gear. So in third gear, we are going to be turning the rear Ravenel sun gear, and we're going to be turning the front Ravenel sun gear at the same time. Now by turning both of those in third gear, that locks up the Ravenel gear set and gives us a 1-to-1 gear reduction on the Ravenel portion, but we still have a 1.95 to 1 in the front. So our overall gear ratio is 1.95 times 1. So third gear ratio is 1.95 to 1 rotations of the input shaft versus the output shaft. All right, so in third gear, that direct drive, we did not lock up anything. So now let's go to fourth gear. In fourth gear, of course, we keep the C1 clutch on because it's on through fifth gear. And now we apply the C4 clutch. The C4 clutch is on in fourth and sixth. It connects this same housing that has the C3 and the C4 clutch packs inside of it. And now it's going to rotate the front sun gear of the Ravenel gear set at a 1-to-1 gear ratio speed versus the C1 clutch turning the rear Ravenel Sun gear at a 1.95 to 1 gear reduction speed. And this is one of those gears that I told you that we are not going to hold anything from rotating. We are actually turning two different Sun gears, two different rotational speeds. Now this was not done on the 6-speed transmission. This is totally unique to this design of the rear-wheel drive or the front-wheel drive transmission here. So the front Sun gear will be turned at a 1-to-1 gear ratio. The rear Sun gear is turned at a 1.95 to 1 gear ratio. That gives us an overall gear ratio of 1.45 to 1 from input shaft to output shaft. So we no longer have just the 1.95 to 1 gear reduction here. We do. We have the 1.95 driving the rear Ravenel Sun gear, but we have 1-to-1 driving the front Ravenel Sun gear. And so, once again, nothing is held from rotating. We're just turning two different Sun gears, and instead of holding the rear Sun gear from rotating, we're just connecting it to the ring gear of the front Planetary gear set that makes it turn half the speed or slower than the input shaft, which gives us an unusual gear ratio that we've never seen before. So that's 4th gear. In 5th gear, we do the same thing. In 5th gear, we turn two different parts of the Planetary, of the Ravenel gear set, two different speeds. So we keep the C1 clutch on, which is used in 1st through 5th gear, which turns it at the 1.95 to 1 gear ratio to turn the rear Sun gear. But then clear down to the bottom of the transmission here, we have the C2 clutch that also comes on in 5th gear. So we have the C1 and the C2 clutch on at the same time. This C2 clutch is splined to the input shaft, and it also is connected to the Planet carrier. So now in 5th gear, we are turning the rear Ravenel Sun gear with the C1 clutch. We're turning the Ravenel Planet carrier with the input shaft, and that gives us an oddball gear ratio of 1.221 to 1 turn of the input shaft versus the output, the counter drive gear here. So fourth and fifth gears had two different components turning at two different speeds. Nothing was held solid, and it wasn't a 1-to-1 lockup gear ratio, so that's a unique thing. All right, for 6th gear, now we are going to release the C1 clutch. We're done with C1 after 5th gear. So C2 clutch down here to the bottom is used in 5th, 6th, 7th, and 8th gear. And so to get 6th gear, we keep the C2 clutch on driving the Ravenel Planet carrier. And now we apply the C4 clutch at the top here, and now we turn through the C3, C4 clutch housing, the front Sun gear of the Ravenel gear set at a 1-to-1 gear ratio speed. So that means the Planet carrier is turned at 1-to-1, and the front Sun is turned at 1-to-1. That gives us an overall, in 6th gear, lockup of a 1-to-1 gear ratio. So 6th gear is 1-to-1 or direct drive on this 8-speed transmission. All right, let's move on to 7th gear. In 7th gear, we keep the C2 clutch on, which is driving the Ravenel Planet carrier. And then we also apply the C3 clutch. The C3 clutch will connect through our C3, C4 clutch housing to the front Sun gear and rotate it at half the speed approximately of the input shaft, which results in our first overdrive gear ratio for 7th gear of 0.809 to 1 turns of the input shaft to the output of our counter drive gear here. So it's going to take 8/10 of a turn of the input shaft to get 1 turn of the output shaft. That's an overdrive gear ratio. And then finally, for 8th gear, we reapply the B1 band brake and stop the front sun gear from rotating. We still keep the C2 clutch on and turn the Ravenel Planet carrier, which gives us an overall gear ratio in 8th gear of 0.673 to 1, so a little over half a turn, about 6/7 of a turn of the input shaft to get 1 turn of our counter drive gear here that drives our counter-driven gear in our final drive for the output shaft. So for 1st, 2nd, 3rd, 6th, and 8th gears, we held something and we rotated something. For 4th, 5th, and 7th gears, we connected 2 different rotating parts to different rotational speeds to different members of the Ravenel Gear Set down here to get us some gear ratios that we've never had before and couldn't get before unless you had a slipping clutch pack. All right, then the very last gear to look at is reverse. So in reverse, we have the B2 brake down here that comes on. That B2 brake is just going to stop the Planet carrier of the Ravenel Gear Set from rotating. And then we will apply the C3 clutch through the C3, C4 clutch housing to the front sun gear and rotate it. And that will give us a reverse gear ratio of 4.015 to 1 for reverse. Now, I couldn't actually show you all of that by rotating components like I do in some of my other transmission videos because it's too complex in connecting different components. I could not figure out a way to do it without covering up everything to where you couldn't see what was going on in the first place. So, simple planetary gear set in the front, Ravenel gear set in the back. It's a real simple design and seems to be working well for an 8-speed transmission. Now, of course, the 9-speed transmissions have come out. GM has their own version of a 9-speed transmission. ZF has had their 9-speed transmission. There's 10 speeds out now. Both Lexus and Ford have 10 speeds. I'm sure there's others that'll come along there also, but none of them have been as simple of a design as this particular one here, in my opinion. All right, now the very last piece to talk about on this transaxle is the valve body. So the SL1 solenoid controls the fluid pressure to the C1 clutch. The SL4 solenoid controls fluid pressure to the C4 clutch. SL5 solenoid controls fluid pressure to the B1 brake. The SLU solenoid controls fluid pressure to the lockup torque converter solenoid or torque converter clutch. SL2 solenoid controls fluid pressure to the C2 clutch. SL3 solenoid controls fluid pressure to the C3 clutch and the B2 brake. The SLT solenoid is our line pressure control solenoid. And then this SL7 solenoid down to the bottom here is used on vehicles that have an idle stop system. And what it does is it will hold the fluid pressure applied to the C1 clutch so that when the engine is off and you restart the engine and start to accelerate away, the C1 clutch, if you recall from the power flow that we just went through, is used for first gear. And then there's a mechanical F1 roller clutch right here that's used for first gear. So if we can keep the C1 clutch fluid pressure high, even if the engine's off, that clutch will still be applied when you accelerate away. And it's a simple way to have an idle stop feature to save on fuel and reduce emissions. There's a temperature sensor that will plug into here. There are 2 speed sensors in this transmission, input and output speed sensor also. And if you are at a Toyota or Lexus store, you can replace these solenoids. If you're at a General Motors or Cadillac or Oldsmobile store, if anything on here fails, you're replacing the entire unit. No replaceable parts, as far as I can tell at this moment. That may change in the future. But even Toyota doesn't allow valve body repairs, only solenoid replacements. I'm not sure what Volvo's policy is. I suspect it's replace everything, just like the General Motors version. Okay, well, this has been a review of the world's first production 8-speed front-wheel drive transaxle made by Aisin. 3 different versions, as I've mentioned in the past. A very unique design, seems to be pretty cool, and is being used widespread, especially in Toyota and Lexus vehicles and Volvo. Thank you for watching.